Let's look at the example that f of x equals a logistic function. X between 0 to 30. Solve for x if the increasing rate is 2. When you talk about increasing rate, we know that is the first derivative. So we will set up the first derivative equals 2. Since we want to use equation solver to solve this equation, so make sure you set up equal to 0. So you get the f prime of x minus 2 equal to 0. Since we cannot decide how many solutions for f prime of x minus 2 equal to 0, therefore, let's draw the graph first. So we will draw the first derivative. Here, we will set up y4 equals 2. Let's sketch the graph now. Now let's change the window. For domain, they give you from 0 to 30. And here, we divided by 10, we get 3. For the y minimum, let's set up -5. Maximum is 5. So check the graph now. Basically, you could say you have 2 intersections, and you can go to second trace 5, enter to get the 2 intersections. But I want to show you using equation solver, even you have 2 solutions. You could say one is close to 0, the other close to 30. So we go to Math, upper arrow, Solver. We will set up alpha trace. Go to y2, that's the first derivative, minus 2. Then enter. For the bound, that's the domain, you can change into from 0. Use this delete button to change. 30. Then for this x, first one, and you will assume it's 1, very close to 1. So I do alpha, enter. You will get the solution, that's 9.24. Then you put 30. 1 is very close to 30, so I put the 30. Then you do alpha, enter. You will get another solution, 29.9. Let's go to the second question. Find the maximum rate of change of f. Maximum rate of change basically means the maximum of the first derivative function. Or since the first derivative function, we're looking for the maximum, which means at that point, the second derivative equal to 0. So you can use either A or B method to solve the maximum rate of change of f. Now we go to this y equals. This time, we want to get the first derivative function to get maximum. Therefore, I only want to sketch the graph for y2. The maximum point is not that clear, so we change the window. This time, let me change into 10 here. Then go to graph again. The maximum rate of change is this point. So we go to here, second trace, maximum, that's a 4. Since each skill is 3, so I can, here's a 6, left bound. Right bound, you could say that's a 30. Then enter, enter. You will see when x equals 19.6, the maximum rate of change is 5. Since the maximum rate of change means the second derivative equal to 0. So you can also use this. I clear the y2. I just want to get the 0 of y3. This is not clear, so you need to change the window into minimum for y, it will be -1. And maximum, let's go to 1, check here. So you can use second trace 0. Then that's the left bound. Here is the right bound. To get the same solution. Also, you can use equation solver for math, upper arrow, enter. So we will set up y3 here equal to 0. Then you have to change this domain. That will be from 0 to 30. Then we assume this x is 10. Then we go to alpha, enter. They give you exactly the same solution. Let's go to number 3. Find f of 10, f prime of 10, and f double prime of 10. So we will go to this graphing calculator. We know the y1 is the original function, y2 is the first derivative function, y3 is a second derivative function. Therefore, I will go to alpha trace, enter. Here is f of 10. Alpha trace, go to y2. This will be the f prime of 10. Alpha trace, we go to y3. You will get f double prime of 10.